Hi, here we have another question from Iran Mathematical Olympiad Round 1 in 1997. The question is that S is equal to this expression. What is the value of S? The actual question was actually this one. Which of the following numbers is closer to S? So we have several options and we want to see S is closest to which value. Round 1 of Mathematical Olympiad in Iran has 30 questions for 3 hours, so you have approximately 6 minutes per question. You can spend between 5 to 10 minutes on this question and then come back and see the solution. What I did is I first tried to evaluate a few terms of this expression by calculating the numbers. So for example, here it's 8 minus 1, it's 7, this is 9, this one is 27 minus 1, so it's 26, this is 28, this is 64 minus 1, 63, 65, and so on. After I did this, I noticed that this 7 can be simplified with 28. So basically 28 can be written 4 times 7, so 7 can be simplified with that. And then I noticed that this 26 is 2 times 13, this one is 5 times 13, so 13 can be simplified. So I concluded that there must be a general expression so that we can simplify these terms with each other, and therefore we will be able to calculate S. Okay, so let's see what we can do. Of course, we know how to expand this expression and how to expand this expression. n3 minus 1 is equal to n minus 1 times n2 plus n plus 1. So we know this identity. And also n power 3 plus 1 is equal to n plus 1 times n2 minus n plus 1. But obviously, we cannot simplify any of these. However, in our previous slide, here we observe that 7 cancelled a term from the next term. Here 13 cancelled a part of the next term. Then I decided instead of evaluating n3 plus 1, let's evaluate n plus 1 power 3 plus 1. So of course will be first one plus the second one, so n plus 1 plus 1. And then will be first one power 2 minus first one times the second one, which is this one, plus the second one power 2. And we can expand n plus 1 power 2, so this would be n2 plus 2n plus 1. Here is minus n minus 1, and this is plus 1, so this with this disappear, minus n with minus n disappears. And it turns out that n plus 1 power 3 plus 1 is equal to n plus 2 multiply n2 plus n plus 1. And now we notice that this term can cancel this term. That is the trick of the exercise. Okay, so now we have this is our expression, and we know that n power 3 minus 1 is equal to this. N plus 1 power 3 plus 1 is equal to n plus 2 times n2 plus n plus 1. So we are going to replace every term with its equivalent. First one, we write 2 minus 1 multiply 2 power 2 plus 2 plus 1. So we use this expression. On the denominator, we have 2 power 3 plus 1. So this is 1 plus 1 power 3, like this. So it becomes 1 plus 2 multiply 1 power 2 plus 1 plus 1. So it's here. And then we have the next term, 3 power 3 minus 1. This is 3 minus 1 times 3 power 2 plus 3 plus 1 divided by 3 power 3 plus 1. We write it as, because here this is 3, so it's 2 plus 1, so it's 3. Then it's 2 plus 2 multiply 2 power 2 plus 2 plus 1. And so on, everything can be written. Obviously, we notice that these terms can cancel out. So we have this expression, this term cancel out, this term cancel out. Everything in between cancels out. So we will be left with this one. The last expression like this cannot be cancelled out. So this one stays. And the other ones are these terms. But obviously we know that 1 plus 2 is 3. So here on top we also have 4 minus 1, which is 3. And then here we have 2 plus 2 is 4. The next one will be 5 minus 1, which is 4. So all of those can also be cancelled. This cancels, this one cancels. So a lot of these terms will cancel out. And then, for example, here we have 100 minus 1 is 99. And in this case, before this term, we will have 97 plus 2, which is 99, so that term will also cancel. And what we will be left with is 2 minus 1 from the first term, this one from the first term, 3 minus 1 from the second term, and then we come to the one before the last term, we have 98 plus 2, the last term we have 99 plus 2, and this term on the denominator. Okay, so we can evaluate this. Basically, it's okay. This is 100 times 101. So this will be 100 power 2 plus 100. This is also 100 power 2 plus 100 plus 1. This is 2. This is 3. And the value will be this one. So obviously the correct answer is this one. If this expression will continue to infinity, then obviously this term and this term, they will become equal, so they cancel out, and s will become 2 over 3. Okay, so what we have learned is to evaluate multiple terms of the expression by substituting numerical values and observe their behavior. So you observe that when I replace the first few terms, I realize that I can simplify the first term, a part of the first term with a part of the second term on the denominator, and so on. So this initial evaluation with numerical values can give you a hint to find the general pattern. The second one is to identify and analyze patterns or relationship between the terms to deduce a general formula or general rule, so that you can use those general rules and then simplify everything to get the final results. All right, this is the end of the video. See you next time. Bye.